Yep, we're on. Cool.
Cool.
Hello, everyone, and welcome to our fifth and final event of this week and for World Space Week events. I'm Anwesha. I'm the Physical Sciences Editor for SATNAV, and today we're going to be talking to Matthew Graham, who is a recent graduate from our university and is currently working in the space industry. So with no further ado, I'm going to start off with my whole list of questions for you, Matthew, and
Cool.
we're going to get started. So the first question, we'd love to know more about yourself, especially your degree and perhaps where you're from, and why did you end up choosing to study what you did?
Yeah, fair. Okay, so my name's Matthew Graham, as you probably know now. I'm from Reading, and I went to Birmingham Uni, and I graduated last year. So I started in 2015, and I did mechanical engineering, and I also took like an industrial year out. So I've got a lot of experience with what any level of graduate. I've done the masters and everything. So I did mechanical engineering there, and yeah, yeah. What's the question really?
So why did you end up choosing mechanical engineering primarily?
Oh, fair. I've always liked building things, and I didn't want to go to a too theoretical stance. So with physics, I personally found it was too much theory, not enough hands-on work, and what I really liked doing was applying the tools that other people have theoretically come up with, and seeing creations that actually I do come alive, which is a lot more interesting than just writing things on a blackboard. For pretty obvious reasons, like rockets go whoosh. That's quite fun to see.
Awesome. So do you have any extracurricular activities or hobbies or societies that you've been involved in,
Oh,
perhaps even before university and even during university that you'd like to
yeah, well,
share?
fair. Well, before university, I was in the CCF with as the cadet force. So part of the reasons why I chose Birmingham was I had the officer cadets. I also do double bass, so I'm in some orchestras, and I got the music scholarship at Birmingham, which was quite good. So I got free lessons with the Birmingham City Symphony Orchestra, so that was really cool. And yeah, and obviously, so I think you might have been able to clock that my hat has got Brum Eco Racing on it. So I founded the Brum Eco Racing team, which is we enter the Shell Eco Marathon. So it's a fuel efficiency, ultra mileage car that we have to build. So it's as far as you can get on a small amount of fuel. You got one person sitting in the car and just drive it. It's an international event with people all over Europe, and well, the best teams in the world actually come in. And we've got the third most fuel efficient car in Britain at the moment, so it's pretty cool. If you are a student who is quite bored in a lockdown, feel free to join. There's still a lot of people who want to do it, and we've got some really exciting things we're doing this year with some machine learning. And even if you're not an engineer, like we've got a lot of things that you can do, whatever discipline you are. You don't need to know anything; you just need to be interested. So that was a shameless plug there. But I also did the Rocket Society as well, Space Soc. That's another thing at Birmingham. Yeah, again, join. They're doing some cool stuff with rockets. And yeah, I did the orchestra, obviously. Don't join that because they're not doing anything. So it's lockdown. You can't have that many people, I guess.
Sure. I'm also a member of Brum Eco, and I can totally agree with everything Matt has to say. They're one of the nicest and most fun societies I've been in, and I'm not an engineer. I'm a particle physics student, and like I didn't need to know anything to do with engineering when I joined. So that's been really nice because they have quite a lot of activities for and different projects that you could take part in without having any experience with the engineering department as such.
And also working with lots of theoretical physicists as well. So I did a summer placement at CERN, which was very fun. Definitely try and apply for that if you can. So I worked with a lot of physicists there, and what struck me was the lack of physical capabilities of quite some of them. So they wouldn't know how to build any of the experiments that they knew theoretically really well. So like it might seem a bit weird to go into car manufacturing, but I mean I'm now do space, and I only really had a background in cars. But the core principles you learn there will make you a much better experimental physicist, like by eons.
Could you share more about what you did at CERN during your summer internship? That sounds like a very interesting thing.
Oh, I think it probably was, yeah, for the physicists out there. Yeah, no, it was very good. So essentially, it's called the summer student internship. It's really fun. You essentially you go out for 3 months or so. You live at CERN itself. So I lived about 50 meters away from where Atlas was. It's amazing. You can go. Okay, maybe I shouldn't be officially saying this, but I don't have a contract with them now. You can go underground and you can explore all of the catacombs in CERN, definitely legally. But officially, I didn't do that. But unofficially, it's really fun. It's like being in a computer game. You're going down all these pipes and it's so amazing. And you can see, you can officially also go to see Atlas anytime because you work there. So what I did is I did work with an outreach group, and we were making really expensive equipment for really cheap prices. So we made an interferometer, which usually costs around like £1,000 or so, and we're trying to make it for 50 quid. So one of my other co-workers, he was trying to make a pixel detector that you could attach to your phone. So you could just have your phone out, attach this attachment, and then you could take photos, and it will show you where like cosmic rays have hit your camera. And he was making that for like £2, and like that's crazy how cheap that is. In fact, I think I've got the setup of this. And this is a bit impromptu, but if I turn off my background, I actually might have the setup already here, so I can show you what I made. I just set that. You can see my garage now. All of that hiding has gone to waste. But if I get the light on that, this device here, you probably won't be able to see the output of it because it is lasers. So this is an interferometer. If you haven't done that yet, you will do that in a bit. But essentially, it just has. So it'll take a few minutes to set up probably, but I hope you can see the principle behind it. That there is a laser diode here, a beam splitter, so that splits the laser light in two. The laser light is all collimated and in phase of itself. So then it reflects on this mirror, and there's a mirror here. And then when it reflects back, you should get an interference pattern there. So it'll take like 10 minutes or so for me to set up, so I probably can't do it now. But
that looks really cool. Does it follow the concepts of a Michelson interferometer roughly?
Exactly. It is a Michelson interferometer. So if you want to build that at home, I mean, that was the whole point of my project at CERN, was that so that you could build it really easily for yourself at home. You can go on the School Lab website and you can download all of the CAD files that are on my table right there. And it is really cool to have just your own interferometer equipment at home. You can see quantum particle effects of light. So you can collimate the light in one axis and then collimate the light in the other axis. And that should stop all light from going through. But then all you need to do is collimate it in this axis. And then suddenly you get all the light back because it's all a superposition of itself. So you can actually do quantum physics experiments with that cost 10 quid. Like, it's crazy. And you don't even have to be good at setting it up. Like, you just twist some knobs and then it goes in. And we made a really easy, like, how to do pack. So yeah, there's a School Lab website. If you just search cheap interferometer, CERN, School Lab, Matthew Graham, it will come up with something. There's CAD files online, and yeah, £10 you can do quantum physics. It's really cool.
It's great. Since you mentioned CAD files, does this mean that you 3D printed every single component for your interferometer?
Yep. So all of the stuff is 3D printed. If you don't have a 3D printer, don't worry. So they do cost now only like £160. So like it's cheaper than a normal printer. But there are companies online that you can just upload the CAD models to and just say, can you print this out? They do it for like 5-10 quid. So even if you don't have a 3D printer, you can get all of this stuff. But definitely invest in a 3D printer. It's been like amazing to have one because you can manufacture literally anything you want, just, printing it out.
That's great. I mean, especially seeing how 3D printing has, pretty much changed the face of modern technology, to be honest, especially with regards to accessibility to resources, to be fair.
Oh yeah, definitely. Like it's crazy how much I've been able to do with the printer. So like the first project I did, I was like, so my sister was going out to New Zealand, so I wanted to get her a present before she left, so I 3D printed her a violin, which was really cool. And like, I didn't need to be good at anything to do that. Like normally to make a violin, you need like 10 years of like woodwork experience. I just downloaded a model of Thingiverse and then I pressed the button and then it printed. It's really easy. So yeah, definitely get it. Like any of your projects that you've got or you can think of, like if you want to make a clock, like you can print out all these gears. If you want to, I don't know, a handle on your drawer's broken, you don't have to buy anything new. You just print one out. It's really good.
Well, it's been really exciting getting to know more about your hobbies and interests, and it's very inspirational as well. I mean, along with whenever we're studying for our university degree, it's always important to kind of also have that avenue to follow things outside of your degree, because that just opens up so many different like perspectives that would be really useful in future career opportunities and so on.
Yeah.
Speaking of career, where do you work at the moment?
So I work at a company called Orbastro, which we're a very new company. It's only like a year old. So it's a startup. What's good about the startup is that there's only like 8 of us working there. So I've like normally as a graduate, if you're going to a big company, you'll become a small cog in a big gear system where you'll be making. Like I know some person he's working at McLaren now for the F1 team, and sorry Mercedes, sorry for the F1 team. And although it's really cool because he's working with Lewis Hamilton and that. He spent an entire year designing the cable ties for Lewis Hamilton's race car. Just okay, that's really boring. But whereas what I've done is, so we build satellites, and we're building a satellite that's going to have a whole array that's going to revolutionize all of small satellite flying. So what we're going to do is we're going to be attaching some special modules to our satellites, and I'm not going to go into too deep detail because some of it is classified at the moment still. But essentially, we're going to send up a whole flock of satellites that are going to work very similar to Starlink, but instead of it working for internet on the ground, it's going to be comms travel for other satellites, and it's going to be ultra fast, like microseconds. And it means instead of someone spending maybe 10 minutes a day being able to communicate with their satellite, they'll be able to do it 24 hours a day. They won't even need like a comm station. They just need an internet connection. 24-hour day connection, and the satellite can automatically update within 20 orbits the trajectory automatically. So you don't have to know anything about satellite manufacture. You just send it up over to us, and we'll, do all the rest. But yeah, working in a team of 8. Get back to that. It's really good because I've designed the whole chassis of the satellite, which is crazy. Like I'm not qualified for this, but I guess I am now. I've done the whole chassis. I'm doing radiation testing for it. You're working there as well, some of it. So we're making a radiation detector as well. So yeah, there's a lot going on with it, and I'm really in the forefront. So it's really good to work at a startup as compared to a big company. Yeah.
That's great to know. And I'm just curious, upon graduating, what drew you more to the space industry rather than any other industry in particular?
Wow, so it just sounds cool, doesn't it?
It does, I will give you that.
So what I was looking for really was small production bespoke engineering, because that's where I think is the most interesting. So if you go for car manufacturing, what you'll be getting into is most of your design work will be not like, is this the optimal way of designing something? There'll be the trade-off of, we need to mass produce this. So you could be designing, the best for thermal combustion of the type of engine or something, but they go, well, we're not going to be able to manufacture this to a high degree. But with space engineering, no one cares. You're going to make one of this, or like they're going to throw a lot of money to make it like that. So you can really get to the top high-tech end of engineering because everything you send out is going to be bespoke. So that was why I went into there, because there's only a few industries like that, and this one's the one that has the most output of usefulness, where it is still bespoke. And it is a style of engineering is quite interesting. So yeah.
So does Orbastro work entirely independently, or does it have collaborations with other industries like SpaceX or the European Space Agency?
So way space companies work usually with this type of one is we build the satellites, but obviously we don't have the capabilities to send it off to space because we're 8 people. We can't build the actual rocket. So we are working with SpaceX through a third party. So we're not directly contacting Elon Musk or anything, but we will be on one of the SpaceX flights of the Falcon 9 or Falcon 10 or whatever they're using now. in February. We've got our slot booked, like you'd book out an airplane flight. So I mean, if you do want to see our space launch, it's sometime in February. We're going to be on one of the SpaceX launches. So we're working with them, and we've got the funding through ESA and stuff, because it's quite important stuff we're doing, because it'll increase tenfold the amount of small satellites that can be produced and lower the ceiling of what people can send out dramatically. So we're working with ESA quite a bit. So they're helping us out with reviews, as also quite obviously there's a lot of regulations about what you can send up to space. So ESA are very heavily setting us through certain paths of readiness to make sure that we're up to a standard. But that's about all we're working with, really.
That's great. So your role at Orbastro, what exactly does it entail, and what sorts of projects are you most closely involved with hands-on?
So my technical role is just design engineer. So that means that well, it's quite vague because it's a startup. I'm putting my hands in quite a few different areas. So if you're working for ESA, say, what your job would be very specific and be very small, and it would be based for a 10-year period on one role. So one of the jobs I was looking at was for this lunar lander that they were doing, and they wanted to have a detection thing for the lunar lander where it looked at the ground on the moon, and it used a computer vision algorithm to, while it was landing, to select flat areas of the ground. So it was all about computer vision and stuff like that, and I thought that would be really interesting to do. But the downsides of those parts of the space industry, so this is when you go to a big space company, is that project will be over 10 years, might not even fly, and you're going to be a small part of a big team that's got Russians, Dutch, Germans, French in it. Like, it's huge. Obviously, everyone speaks English, so you don't have to worry about learning that. That was the one thing I learned in CERN. It's just like I worked solely with German people. I've got a German GCSE, and that's what they prepared me for, and they didn't speak a word of German to them. I wanted to, but they're like, no, speak English. So don't bother with your languages. Everyone speaks English. But yeah, so with Orbastro, because there's only 8 of us, it's very different from a normal space industry role. So at the moment in order to get something space qualified, you have to do vibrational testing and vacuum testing. Those are the basic ones you have to do, and then radiation testing. Because when the rocket shoots up, it vibrates quite a lot, about 100 Gs of vibrations. And they're signed vibrations and random vibrations. So you have to do both of them. So what I've done recently is we built a prototype of our chassis, and we stuck it on a big bed that just shook really fast. And we did all the tests based on whatever spec ESA sent us, and it worked. So I had to, obviously before doing that, you have to make sure it works first time without the simulation, because without the experiment. The experiment is just there to validate your simulation, not the other way around. So
Right.
obviously I had to do the maths first. I didn't just stick a lump of steel on a thing and go, oh, it works, wow. I knew it was going to work beforehand. So there was that analysis beforehand, and then we also stuck it in a vacuum chamber, and you just want to see outgassing. So that's if any small particles are stuck in. So there's a lot of material science that you have to know for that. So it's just if there's particulates in certain materials, they can get expelled when it's in a vacuum. And then radiation, we did really badly on that. We went to a particle gun, and we shot tons of high energy protons at it, and we made everything radioactive. So it's now stuck in Manchester. We're not allowed to pick it up. So that was a learning curve. Yeah, I think we made cobalt 52, which has got like a half-life of like 14 hours. So it should be fine in a couple of weeks. But yeah.
I mean, I guess that's one of the nicest parts of getting hands-on jobs or experimentalist nature jobs, which is just that you get to see the physics and the actual engineering in action, and it's always fun when things go slightly not as expected, because you learn something new. Now you have radioactive stuff, which is really cool.
Yeah, and it's a little phenomena that you'd forget about, or your sim might not even think about. Like, you can get by knowing everything theoretically, but if you haven't done something physically, even if you do the theoretical thing once physically, you learn 100 times more than what you did by just looking at models in Python. Like, yeah, you really get to know it. Like, yeah, don't stick all your stuff just in front of a particle gun for 10 minutes because you create isotopes.
Absolutely.
Yeah.
What has been your biggest challenge so far with your new job?
Ooh, I don't know. I think it was trying to prove myself to a new environment. So especially because it's a startup, and I think you'll get this anywhere in your job. Like when you're running a student society or in a student society, the top dog has only been doing it for like 2 years, and he's just a student or she's just a student as well. But I'm now working, like the youngest person there is 29, and he's got a PhD at Cambridge and 10 years of experience in space. Like that's all he's done. And I'm a graduate and I'm supposed to be at the same level as him. And luckily, I've been doing really well. But I remember, they did some, the people there were sizing you up when you were getting in to see if you're useful or not. So it was a bit hard. But I managed to because I'd done a lot at uni. I think they underestimated what I knew. But yeah, so I think that was it. And then also learning the new CAD package, which is crap. If you're ever using Siemens NX, don't. It's rubbish. So.
These CAD packages?
Yeah, so the 3D modeling. So I'm used to in uni you use SolidWorks, and I'm also used to Fusion
Right.
and Inventor. But yeah, they use a thing called NX. So if you're a guy or a girl who's going to a company and they say we use NX, just leave.
Well, looking at the circumstances of the world right now with COVID-19 and the pandemic and the lockdown, I guess I was just curious, has COVID-19 impacted the space industry or in particular your industry in specific?
So luckily, COVID doesn't go to space, which is quite good. Um, but no, in seriousness, I think wider jobs in engineering, it's expected that 30% of them are going to leave the UK by the end of this pandemic. And that's also because we've got Brexit happening as well at the same time. Um, so, and that's a fact. So, like political affiliations aside, there, the engineering climate in the UK is really going down, especially in the car industry. That is the one that's most hit, which is expected because we're going for green cars. So I don't think that's necessarily a bad thing because, like, obviously we want to have green cars and petrol cars are what we make. So of course they're going to be going in declining. The space industry has been largely unhit by this because we still need all of the space stuff, like the way we design and build and our business model works. You're not gonna, other than the fact that research has slowed down a bit, so we haven't had as many of that. But the way it works, it's not as if you people have started using Amazon rather than sending stuff to space. People are starting to use satellites more because they're using Netflix or things like that. Starlink's going up to help people with their internet and stuff like that. So the space is still a frontier that's developing, but within the global market of COVID, yeah, it's it's very uncertain. So I wouldn't want to say anything about that, but I think it's going to be bad, whatever it is. In terms of personally working from home, it's just like uni projects. Like you just sit on a computer and do your maths there. Like yeah, like in terms of any STEM field, working from home shouldn't be too different from working at the office. Obviously, I need to be in the office a lot more because I'm physically making stuff, but that's been fine. You just wear your mask and then, yeah.
Perfect. From your experience so far, what are maybe top 3 must-have skills to thrive in the space industry?
Yeah, fair. Okay, let's go for it. I think you need to have just. I know it's going to sound really cheesy. You need to have a passion for engineering. No, but like you need to just like if you do this as a hobby, like I do, you learn so much more than what you're learning in your course. Like if you're a person who's just done the course in engineering, you're going to be okay. Like yeah, you can probably maybe get onto a grad scheme. Like you probably will actually, but like the amount of physical knowledge you know about the industry is just dramatically tiny. Like if you're a person who's in a position now and you're doing a master's in engineering, and I said I want 6062 T6 aluminium, and you don't know what I just said there, you need to learn that. And you only know that from building stuff. So what I just said was a designation of aluminium. 6000 series has got a high silicon magnesium content. So that's a standard construction series. And then T6 means you've artificially age hardened it. And it's the strongest type you can get there. And then if you know a rough, you don't need to know all of your megapascals off by heart, like yield stress, but like that's about 350 megapascals yield stress, I think. If you know that, that's what you need to know. You need to have a general understanding of what material properties are. You need to have a general understanding of engineering. And you only get that from doing it. Like I came to uni knowing literally nothing. And then I started this society and I joined the society and I learned everything. I remember the technicians laughing at me because I said, oh, why don't we just weld the aluminium to the steel? No, you can't do that. That'll cause just fires and everything. But I only knew that after I'd made all the mistakes. Like the people who know everything have made the most mistakes. I've made so many fires. I made fires. Like we were in our competition, and I didn't know carbon fiber was conductive, and we had oil all over the car, and we were trying to start the brakes on our car to test the brakes worked. The engine just started, then there was a fire, and this was while we were testing the brakes officially with like the Shell people, and it was just like, well, we've learned that now. So some of these might sound really trivial, dumb stuff, but like it's all of these little tiny soft skills, and you will have gaps in your knowledge that you only know from just doing engineering, and it's not hard to learn. It's just you have to really know. You need to just do it. So I think, all of the three things that I think you need are just one thing, and that's just you need to do it a lot. I'm not that much smarter than anyone else. I don't think I'm the smartest one. I was definitely one of the dumbest people at my school. But then when I came to uni, all I did was mess around with electronics or make rockets and explosives and stuff like that. And it's fun. It's really cool to make things work, and that's how you learn. Like that's the only way I've learned. So yeah, that's what I'll say on that really.
I believe that was actually some invaluable advice for anyone hoping to pursue a career in engineering or any sort of hands-on STEM field, because yes, without experience, it is a bit of a drawback, to be fair, with when you do head into the actual industry. Well, since we're nearing the end of the interview, I have one final question for you. What would be your tips for future engineers, or would you have any tips on how they should go about internship searches or any sort of work experience searches?
Yeah, that's fair. So it's going to be different with COVID because it's going to be a lot more harder. So don't worry if you can't get an internship. So when I was first searching, so when I did my second year, I wanted to get a summer internship because I wanted to get some money, and I wanted to, well, obviously get experience. I couldn't get any. None of them responded to me or anything like that. Do not worry about getting all these rejections. Everyone gets tons of them. They get like thousands and thousands of applications for one place. So don't worry that you get rejected. Everyone does. Even if you're Stephen Hawking, they'll just reject you because, I don't know, they'll be like, oh, we don't like people called Stephen. Like they just need to get rid of as many people as they can. So they already have enough people that are of high qualification. They can just arbitrarily remove half the people and still have the same talent that they want. So don't worry that you're not getting an internship. So good places to look on. There are some websites which I'm sure there can be links to at the end of this interview. But yeah, you can just search through them and just apply for that. But if you just know the industry well enough, like with CERN, I just was like, CERN's cool. Let's see what they do. And then I applied, not thinking I would be able to get in. And I applied half as a joke because there was a guy that I knew who was really stupid trying to get in. And I was like, well, that'd be fun if I met him up there. And I applied and I got in. And it was crazy. You put in the keywords. Like I put in that I do 3D printing. I got into a job at CERN doing 3D printing. Just put in little keywords that you have, buzzwords and stuff like that. But like you find opportunities at very odd places. So don't be upset if you can't get something, because you might find something even better down the way. So I didn't get my industrial placement year. And that was a blessing, because I went up to my lecturer and said, can I just do research for you? And he said, yeah, sure. Yeah, I want to research with you. So I managed to just do work with Professor Carl Dern, top lecturer in the whole uni. And I did work with him and Amir, doing fallopian tubes and detecting expansion rates of them to cure infertility. Really cool thing. And then also, the thing is an industrial year costs like $3,000. Why pay that? It's just a name. I've got the experience of the industrial year and I didn't pay a penny. So that's my secret there. But you find out opportunities if you just ask people and push yourself. You have to be a bit annoying because you have to really push yourself in. But like if you just ask people stuff, they'll usually get you things. Like, yeah, and you find like I was playing Dungeons and Dragons with my friend once, and he just went, oh, there's a guy I was working with and he's just left for Malaysia. So now we need someone who can do CAD. And I was like, oh, I can do CAD. And he was like, do you want a job? And I was like, yeah, sure. And then like 2 a.m, he was like, yeah, I just talked to my boss. Do you want to come in tomorrow? And I was like, you mean today, right? And he's like, yeah. So I got the job at 2 a.m. I turned up at 9 a.m. and it was Imperial College London. I built a pilot plant. It was really cool. So like these things, you'll get stuff like they happen at really weird times. So yeah.
That's really, really exciting to know, especially the 2 a.m. story of bagging that CAD job. Congratulations.
Yeah.
I guess one of the key things that I personally took away from that bit was that being proactive is definitely key to this, and just having that consistent, persistent attitude towards, actively searching for opportunities, and instead of just, going the normal one lane way.
Yeah.
And
like even if you find a company, like what I was doing when I was trying to find my industrial placement was I literally just was searching up random companies, and then I'd find their HR department or just some email, and I'll just email them and be like, hey, I work hard, can I have a job? Like, you never know. Like, obviously I didn't get anything from them, but like you could, like, you never know.
Exactly. Well, that brings us to nearly the end of this session. It was absolutely delightful talking to you, Matthew, and I'm sure our viewers will have a lot to learn from your experiences and the tips that you have to offer, especially our future aspiring STEM students and engineers.
Yeah.
Well, thank you everyone for joining us for this interview. And this brings us to an end to our World Space Week events, which was a collaboration between AstroSoc, SpaceSoc, SATNAV, and WISE. We will leave some interesting links in the description, including the link to Orbastro and CERN as well, as Matthew really mentioned that, and their researchers quite enthusiastically.
Yeah.
Do follow us on all our social media pages as we have advertised, and we will keep you updated with events as they come by. Once again, thank you for joining, and thanks, Matthew, for your time.
Cool. Thanks for having me. Cool.